even identities and odd identities. So the naming of these identities has something to do with odd functions and even functions. This was introduced to you way back in, I think, junior high school. Junior high school when the topic of polynomial functions was introduced to you. So what is an odd function? Well, an odd function is something like this. If f of minus x is equal to negative f of x, for all values of x in the domain of this function, you would say that this is an odd function. And an example of that is this one. F of x is equal to 5 times x cubed. So if you want to test if your function is an odd function, you must test if the function meets this criterion. F of minus x is equal to negative f of x. So what you do is you compute for f of negative x. Okay? What is that equal to? Well, f of negative 5x, no, f of negative x is equal to this, 5 times negative x, all of that raised to 3. And you know the rules on exponents, okay? You have a negative 1 coefficient here, negative 1. And so negative 1 times negative 1 times negative 1 is negative. And so it's equal to this, negative 5 times x cubed. But what is f of x? Or negative of f of x? Negative of f of x is just this, negative 5 times x cubed. And so they are equal. They are the same. F of negative x is equal to negative f of x. And so this function is an odd function. So that is how you show, or that is how you verify if a function is an odd function. Now, obviously, if you have an odd function, you have an even function. And a function f is an even function if this is true. If f of negative x is equal to f of x for all values of x in the domain of our function. Well, this one is one where it's easy to produce an example because obviously the simple quadratic function is going to be an even function. Why so? Why so? So again, what is f of negative x? F of negative x is negative x, all of that raised to 2, and it's equal to x squared. So f of negative x is equal to f of x. This function, this simple quadratic function, f of x is equal to x squared, is an example of an even function. Okay, so this topic of even identities and odd identities have to do with odd functions and even functions. So what are the even identities and odd identities? These are the even. It's the cosine. Cosine of negative t is equal to cosine of t. So what that means is, okay, example, cosine of negative pi. And you know that cosine of negative pi, okay, so if this is your rectangular coordinate system, you will trace an angle in your unit circle whose radian measure is negative pi, okay, because this is done in the clockwise direction. And you know that this is equal to negative 1, okay? So you will pay attention to the x coordinate of that point, and that x coordinate is actually negative 1 and 0. What is cosine of pi? Well, what you will do is you will rotate your angle by pi radians counterclockwise, and you will fall on the same terminal point. And so cosine of pi is also negative 1. So that is what it means to be an even identity, okay? Cosine of negative t is equal to cosine of t. So cosine is an even function. And so we have this even identity. What else? Obviously, it's also true for second function because second is the reciprocal, okay? So second of t is 1 over cosine of t, Okay, so if you have something like secant of negative t, so that is equal to 1 over cosine of negative t, but cosine is an even identity or an even function. So it's going to be equal to 1 over cosine of t, and this is secant of t. Okay, look at that. It's equal to that. So cosine and secant are even functions, and so we have this even identities. What about the odd identities? So these are the odd identities. Sine of negative t is equal to negative sine of t. Cosecant of negative t is equal to negative cosecant of t. And the same with tangent and the same with cotangent. The only even identities will come from cosine. Cosine and its reciprocal, which is the second function. You know what? When you cannot recall why this became to be true, okay, why is it that cosine of negative t is equal to cosine of t? And why is this true? All you have to do is bring back your unit circle and trace an arc. Trace an arc whose lengths are t. Okay, so this is t. That is t. And another arc whose length is negative t. Okay? And what you do is you pay attention to the terminal points of those arcs. The terminal point of t and the terminal point of negative t. That point defines an isosceles triangle. An isosceles triangle whose legs are equal or congruent because it is an isosceles triangle. The length of those legs is equal to 1. This one, 1, 1. Those are the radius, the radii of your circle. And so this is y, okay? This is y, and this one is x. So these 2 points have the same x coordinates. So what does that mean? Well, that means that cosine of t is equal to x, and cosine of negative t is also equal to x. And what about sine? What about sine? So you will pay attention to the y coordinate of those terminal points. So sine of t is equal to y, the second coordinate of the terminal point. But what is negative sine of t? So this means negative sine of t is just negative y. Now, you evaluate sine of negative t. What is sine of negative t? So you pay attention to this, to the terminal point of this arc, which is below the horizontal axis, and it is equal to negative y. And so you have it. Sine of negative t is equal to negative sine of t. When you are kind of confused, recalling which is the even identity and which is the odd identity, you go back here to your unit circle. Trace t and trace negative t. Look at their terminal points and evaluate cosine of t, cosine of negative t, sine of negative t, and sine of t.